today we're starting Trig, like I said before. And what we're going to be talking about today is we're going to be talking about something called radians. We already know what degrees are, right? So now we're going to start talking about radians. When we talk about radians, we need to start thinking in terms of pi, in terms of angles. So you guys spent a lot of time last year in geometry talking about angles, right? Did you talk about reference angles by any chance? Coterminal? Terminal, anything like that? Okay. So what we're going to look at is first we have to talk about a little bit of vocabulary and some things that go along with different types of angles. Okay? So the first thing we're looking at is something called standard position. And I'm going to give you the definition. I probably should have typed it in for you. I apologize. Next time I'll type it in. Okay? So standard position, we're going to say if it's vertex. Yep. Remember, it's under a different folder. It's under the folder Intro to Trig. Okay? So if it's vertex, what's a vertex? Should know vertex. Where the two connect, okay. If it's vertex is at the origin, you know what the origin is, right? Yep. And its initial ray points along the x-axis. So these notes, there's a little bit of typing, but once we get past this, it's not too bad. We're going to see a picture of this in just a moment, okay? So if the vertex is at the origin and its initial ray points along the x-axis, we call that standard position. Origin is what? What's the point? What is it? Origin? 0, 0. So what you're thinking of, you should be thinking of an x and y coordinate, x and y axes. Standard position, which means its vertex is at the origin. Okay? That would be in standard position. Okay? It makes an angle with the x-axis. We all have that typed in? You need another minute. All right, positive and negative rotations. Now, this is a little bit different from what you're used to. A positive rotation is going to be counterclockwise. So counterclockwise, which means you're going to move, right, the opposite way of clock goes. So counterclockwise, and what do you think negative is going to be? Clockwise. So if you're going positive rotation, you're going counterclockwise. Negative, you're going clockwise. All right, coterminal angles. Coterminal angles are any two angles drawn in standard position that share the same terminal ray. We'll talk about what that is in just a second. So any two angles drawn in standard position that share the same terminal ray. What does the word terminal mean to you guys? You guys think airplane, okay. Finish. Internal, okay. Terminal. If you have a terminal illness, what happens to you? You die, so your life ends. Okay, so terminal is where your angle ends, at the ray at which it ends. Okay, so that's what a terminal ray is. All right, reference angles. Are we ready for reference angles? Okay, reference angle positive acute angle formed by a terminal ray and the x-axis. Okay, so what's acute? Smaller than 90. Terminal ray, terminal meaning where it ends, and the x-axis. Okay, so we're talking about an angle that's going to lie in what quadrant? In the first quadrant. If it's less than 90 degrees, its terminal ray lies in the first quadrant. Okay. All right, so this is the vocab. I'll probably give you a quiz next week on the vocab. How many of you have had a vocab quiz since you've been in high school? Probably not many, right? Vocab quiz next week. Okay, so let's look at the next page. Here's pictures of what this all means. Okay? Notice I've got my quadrants labeled 1, 2, 3, and 4. This is my x and y axes. I have a circle that goes around, right? Now, this is my initial ray. I'm going from the origin along the x-axis, right? It's opening up. Here's my angle here. I have an angle here. This is the terminal ray. Why do we call it the terminal ray? Because that's where the angle is ending. I should have narrow, but I couldn't figure out how to do narrow. So this is the angle, okay? So initial ray, terminal ray, this is the angle. Are you okay with that? Notice the initial ray starts on the x-axis. That's what, yes, that's where they're going to start, okay? This is the reference angle. What do we say reference angles had to be? Positive and acute. So does this look like it's going to be less than 90 degrees? Yeah. So the way we find reference angles, which we're going to look at in just a moment, is we figure out what it would be. Notice it's to the x-axis again, right? How big the angle would be to the x-axis, so the remainder of it, okay? How would I find this angle from this one here? Good. You take the big one, our main angle, subtract from 180, that's going to give you your reference angle. Very good. So all you have to do is really look at the picture to see what do I need to subtract. 180, 360 gives you an idea. Okay? Are we okay with that? We're okay with terminal ray? Initial ray? We know standard position starts x-axis in the origin. So that's where we're starting from, is the x-axis. No, we start with standard position. Yeah, it's rare that they're going to give you an angle that starts at 90 degrees and moves around. But if it did, could you figure out what it was? If I went from here to here, it would still be 90. Okay? All right, let's look at the next page. Take a picture. It's going to go on my list of things to do today, figure out why it does that. Okay, so we're going to answer the following questions. You may need scrap paper for this or the back of your homework assignment. Answer the following questions by drawing a rotation diagram and identify the quadrant where the terminal ray falls. Okay, so you want to do this on scrap paper or paper that you're going to put into your folder because this goes along with the notes. So if we want to draw a rotation diagram, all we're drawing is the axes. And we know if we're drawing an angle, where are we starting? On the x-axis, and we call that what position? Standard. Okay, so I want 145 degrees. So I'm going to start here. What quadrant is my terminal ray going to land in? Second quadrant, because we know once I hit here, that's 90, and then here is 180, so I know it's going to be somewhere in between. So quadrant 2. Quadrant 2 is what you should put in your calculator. Okay? Easy? Hard? So that's positive, right? That's the positive direction. When we get a little further down, you'll have a negative one to try. So you're still going to start on the x-axis, but which way are you going to rotate? The other way. So why don't you fly through those real quick? We'll go over them in a minute. Okay, so we already did A. Let's talk about B. 320 degrees, I'm going to wind up where? What quadrant? Fourth quadrant. Any problems with that? Okay, 72 degrees, Mooch. What quadrant? Good. And then D. Okay, D is negative. So what was the hint with the negative? What did I have to do? Clockwise. So I'm going to go negative 90, negative 180, and negative 210 would be somewhere in the third quadrant. How do we do with these? Not too bad? Nope, the quadrants stay the same. This is quadrant 1, 2. Did I write 3? Sorry. 2, 3, 4. Sorry about that. I don't know why I did that. Okay, so negative, you go in a clockwise direction, positive counterclockwise. Are we all good with those? I'm going to move on. Okay. All right, so standard position starts where? X-axis, and terminal side or terminal ray tells us what? Where it ends. Okay, excellent. Good, good, good. All right, so you can go ahead. We're going to do this question real quick. In which quadrant would the terminal ray of an angle drawn in standard position fall if the angle measures 860 degrees? So go ahead, take about 30 seconds and find it. It's under, okay, so who's got the answer for me? Dan? Quadrant 2. Does everybody agree with quadrant 2? Nice job. Any problems? Mike, I'm going to take that phone and I will have it for my own. Thank you. All right, good. Let's move on. All right, so given a negative angle that is coterminal with each of the following positive, that should say angles, agonals. I didn't catch that. I'm usually, oh, come on. Oh, it's doing it again? I've been pretty good about spelling lately. Okay, so what I'm doing here is I'm looking for a negative angle that's coterminal with each of the following positive angles. So what that means is if I have, do you guys know what this symbol is? Alpha. Alpha. You have to get used to that. Okay, alpha. All right, so what I have is I have an angle of 90 degrees. 90 degrees is what? Where's 90 degrees? Straight up. So here's my angle, 90 degrees. I want a negative angle that's coterminal. Coterminal means they share what? The same spot. Give me a vocab word. The same terminal what? Ray. Okay, it has to share the same terminal ray, and it has to be a negative angle. Okay, so my coterminal angle, if it's negative, which way am I going? So my coterminal angle is this angle here. What angle is that? Negative 270 degrees. Does that make sense? The degrees is control apostrophe. So right next to your book, I believe. Control apostrophe, did that work? Yeah, okay. All right, so coterminal means it shares the same what? Terminal ray. Okay, good. So that's negative. Could you guys tell me a positive coterminal angle? It's got to share the same terminal ray, and it's got to start at standard position. Think big. I'm going to start here. I'm going to go around 360, and then I'm going to Add on another 90. That's also coterminal. So what's 360 plus 90? So 450 would be my positive, whoops, my positive coterminal. Does that make sense? Because they share the same what? Terminal ray. Okay? So those are coterminal. Does that make sense to you guys? This is just saying negative, but I wanted you to see both. Okay? So you're going to find the negative coterminal angle. I'd like you to do, let's see what the fourth one looks like. Yeah, do those four real quick. Find me, or the next three, find me their coterminal, negative coterminal. All right, so 330 degrees. If I graph this out, it's going to wind up in my fourth quadrant. Here's my angle, correct? All right, to find its negative coterminal is going to be this part here. What did you do to find it? Subtract it from 360. And I get 30, but what do I need? The negative, because we're moving in a negative direction. Are we okay with that? All right, so now I'm just going to ask for answers. 120 degrees, Kevin, what'd you get for its negative coterminal? Perfect. And notice what happens. What's 120 plus 240? Okay. 330 plus 30? 360. They're going to add up to 360s or multiples of 360 if you're finding the positive. Okay? All right. Oops. Thank you. And 210, let's have Edith. Is everybody okay with these? All right, let's move on. You guys are doing a nice job. All right, so coterminal angles are drawn in standard position. We'll always have a measure that differs by an integer of multiple of, what do you think? All right, so let's go a little bit further now. We've got coterminal, we've got standard position, we've got terminal ray, initial ray. We've learned some things, right? Okay, for each of the following angles, beta, that's that funky looking B is beta. We have alpha and beta. 360. Draw a rotation diagram, then state beta's reference angle. What's a reference angle? The little part. Give me a math word for small angle. Acute. Okay, so a reference angle has to be, that's not how you spell reference. Reference angle has to be less than 90 degrees. Okay? So when you get the reference angle, it should lie in the first quadrant, correct? All right, so beta for the first one is 160 degrees. So let's draw our diagram. 160 degrees is going to be in what quadrant? Second quadrant, so I'll put it about here maybe. Here's my angle. My reference angle is an acute angle for which it forms with the x-axis. Okay? So where's my reference angle? Yeah, this little piece. It's going to form it with the x-axis. Okay? How do I find that angle? Think about half a pizza. Huh? Good. We're going to do 180 minus the 160, which is going to give us a reference angle of, what happens if you get a value that's greater than 90 degrees? You got it wrong, because reference angle says it has to be an acute angle, right? Okay. So similarly, 300 degrees, where's that going to lie? Go quadrant. Okay. So here's 300 degrees. How am I going to find that piece? Subtract it from 360. Good. So are the pictures helping? Help you to realize what you have to subtract from? If you're only dealing with half a pi, it's 180. If you're dealing with the whole pi, it's 360. No, because it's always a positive acute angle. Okay? All right, so I want you to try the next few for me. Okay, so let's have Fran give me the reference angle for 210 degrees. 60 degrees. Everybody agree with that? Troy, can you give me the reference angle for the next one, which I can't see? I don't want to move. 12 degrees. What's the actual angle? $78 degrees is a reference angle. So that one you don't have to change. That was a trick question. I am awful, aren't I? 78 is a reference angle because it's in the first quadrant, so you wouldn't have to change that one. Okay. If you have one in the, say it again. I don't know. I was trusting you. Okay, 210 is 180. It's here, right? You got to go to the x-axis. So that would be 60. So 180 plus 60 is 210. So for this one, you could do it one of two ways. You can find out how far past 180 it is, or you could do 360, not 3,600, 360 minus 210, which is going to give you 150, and then 180 minus 150 would give you, it should be 30. 30. Yeah, you go back to the x-axis. So what's 210 minus 180? 30. It's 30. Yeah. Because essentially what you're doing, if this is 210, if you subtract out the 180, you're getting rid of this, which is just going to leave the angle that you want. Why would you use 270 minus 210? Well, yeah, you could do that too. That would work as well. Sure. There's multiple ways to do it. We just have to find the right match. Okay. All right. Where do they go? They go right here. They take pictures of all of my ink if I want them later, which I never do. Okay, so now that we know a little bit about angles, let's talk about something called radians. Radians, the radian angle, we use the term theta. Have you guys seen this before? No, never seen theta before. Okay, so this is theta. It's kind of like, there's different ways to write it. It's kind of like an O with a little hat on. Okay, so that's theta. The calculator doesn't do it with a little bit of tail, but I do. So if I write it that way, that's what I'm talking about. Okay, this is theta. T-H-E-T-A. Theta. All right, so theta is created by rotation around a point A using a radius of r, passing through an arc length s. So we have a very nice formula, theta equals s over r, or s equals r theta, theta r. R stands for radius, just like it always does. S stands for arc length, and that's something you're going to have to get used to. Okay, S stands for arc length, and I'm going to show you a picture of what this actually means in just a second. Picture. Okay, so this is what it is. Here's our point A. It's a rotation around a point. Okay, so if we're rotating around a point, we're keeping the same radius. It's being rotated. The angle that it's creating is theta. The arc that it's creating is s. That's our arc length. Okay, so s equals r theta is the formula that we use. So why don't you put in a text box? Do you guys remember how to do that? How do we put in a text box? Menu, actions, text. So I want you to put in a text box, I want you to write out S equals R theta. Where am I going to find theta? Look down here on the bottom. It's already there for us. We don't have to find it. And enter will store it. Okay, S equals R theta is the formula that we use if we're missing one of these pieces. If I'm missing the radius, I want the radians, or I'm missing the arc length. And this gets used a lot when we talk about real-life applications, rotations around something, pendulums, things of that nature. Okay? All right, so let's look at the next page. All right, consider a full rotation around any point in the counterclockwise positive direction. Full rotation is going to mean how many degrees? 360. Okay. What is the arc length S in terms of the radius, the circle R, for a full rotation? Okay, so you just told me. What is the arc length S in terms of the radius for the circle R for a full rotation? Okay, so okay, so you just told me that for a full rotation it's going to be what? 360. So if we have a formula, S equals R theta, what's going to be 360? S. Okay, that makes sense, right? That's the arc that it's creating when it's traveling around the fixed radius, around the point. Okay, so based on that, S equals R theta, 360 equals R theta. How many radians are there in one full rotation? Based on the definition on the last page in your answer to part A, how many radians are there in one full rotation? Remember, radians is theta, right? So how am I going to get that alone? Divided by R. So 360 divided by R, which is what? What's R? Yeah. It's going to tell me how many radians I have. Okay? And this will make more sense in a minute. I don't really like that question. I think I'll take that out next time. Okay. But it'll make more sense when we apply it. Okay, so basically what this is saying, and what I need you to remember, is that in one full rotation, which is how many degrees? 360. That's going to be 2 pi radians. Okay? So 360 degrees, I'd like you to write that. 360 degrees is going to be the same thing as 2 pi radians. So 2 pi's is going to be 360. So what do you think 180 is going to be? 1 pi. What do you think 90 is going to be? Half a pi, pi over 2. Make sense? Okay, so 360 degrees is going to be 2 pi. So what's pi equal? In radians? 180. Good. Because if 2 pi is 360, what would pi be? 180. Okay, so when we're thinking in terms of radians, we're thinking of pi as 180 degrees. Okay? And you have to get really comfortable with that. All right, go to the next page. All right, determine the number of radians that the minute hand of a clock passes through if it has a length of 5 inches and its tip travels a total distance of 13 inches. All right, so what I always do with these is I draw a picture. If I have a clock, I have a center point that holds my hands, right? Okay, so what it's saying is that the minute hand of a clock passes through if it has a length of 5 inches. So here's our, what is that? Radius. And it travels a total distance of 13 inches. So what's that 13? S. S stands for, remember, we're dealing with S equals r theta. So we've got the radians, we've got the arc length. What are we looking for? Determine the number of radians, right? So we're looking for theta. So how am I going to find theta? We're going to plug it in. 13 equals 5 theta. How are we going to get theta alone? Okay, so theta equals 13/5, which in a decimal would be 2.6 radians. So 2.6 radians. Okay? The radians don't always have to be in terms of pi. A lot of times they are, but sometimes they are not. Okay? So 2.6 radians would be my solution here, using S equals r theta. Okay, so whenever you have something that's talking about an arc length and a radius, you're going to use S equals r theta. Okay, so let's go to the next page. So here's another one. Like I said, a lot of these questions are pendulum questions or minute hand questions, clock questions. If a pendulum swings through an angle of 0.55 radians, what distance does the tip travel if it has a length of 8 feet? So what values do I have here? I've got pendulum has a length of 8 feet. So that's r. Travels an angle of 0.55 radians. What's that? Theta. So what is it that I'm looking for? The arc length. Okay. So what formula do I use? All right, I want you to solve for S for me, arc length for me. Troy, can you set it up for me? Okay, and what'd you get? 4.4 units. Feet. It's a distance. Okay. Good. Okay so far? All right, so that's the formula, S equals r theta. They test it usually once, maybe twice on the regions. Okay. All right, so it's also very important that we're able to go from radians to degrees and degrees to radians. And there's a formula which helps us to do that. Okay, so you're going to have to enter in the formula here. Okay, fraction. And if you want to write it out or if you want to put the symbols, I don't care. It's up to you. The formula is degrees over radians. So if you want to write it out, fine. I'm going to shorthand and put a degrees symbol and a radian symbol equals 180 over pi. And we have a pi key. So degrees over radians equals 180 over pi. And if you want to write out degrees and radians, awesome. You can do that. I'm just going to shorthand for now. So degrees over radians equals 180 over pi. What's pi equal? 180. What's 180 over 180? Okay, so this is why it works. It doesn't change the value. It just makes it look different. Okay? Okay, so this is the formula we're going to use. So let's go down here. I've got theta equals 90. I want to convert degrees into radians. I want to change this into radians. Now, if we remember our rules, that 360 is 2 pi, 180 is pi, what's 90 going to be? Half a pi. And how do you write half a pi? Pi over 2. Pi, there's a pi key right there, right next to the on button. So if you know those rules, some of these you don't even have to use the formula. These should be quick and easy right off the top of your head. Okay, 0, 0, 90 is pi over 2, 180 is pi, 270 is 3 pi over 2. 360 is 2 pi. You're just going to learn to memorize those. Okay? They'll make sense to you. Now 120, it's not nice and easy for us, so we do actually have to do the calculation for that. So how am I going to set up the math? I'm going to move that over so I have more. No, 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 no. Aw. It's not funny. No laughing at me. What was it, 120? Okay, so how am I going to set it up? My formula, degrees over radians. So degrees over radians equals 180 over pi. So how the heck am I going to solve that? Cross multiply. Good. Okay. So what happens when I cross multiply? Good. Isn't it ridiculous that I have to keep pushing this when I can hit it once and it will keep going forever for no reason? Okay, so 120 pi equals 180 theta. Am I done? What do I do? What am I solving for? Say it louder. Theta. I'm solving for theta. So how do I get theta alone? Divide out the 180. So I have 120 pi over 180. My nice recorder's in the way. 120 pi over 180. Think that's in simplest form? You guys know how to get simplest form on your calculator? Control I at a calculator page. I want to reduce 120 over 180. Please put in the fraction 120 over 180. So Control I, add a calculator page, put in the fraction 120 over 180. To get it in simplest form, hit enter. It will reduce it for you. So, in simplest form, what is my answer? 2 pi over 3. Good. That is 120 degrees in radians, 2 pi over 3. Okay? This is important that you guys know how to do this. I want you to try C. Let's have Julie set it up for me, please. Okay. Now what? Okay. Say that again. Excellent. How many people got that right? So what's the formula? Yeah, degrees over radians equals 180 over pi. Better memorize it. Degrees over radians equals 180 over pi. Okay. Next page. All right, so now we're going to go from radians, and that is not how you spell radians. We're going to go from radians into degrees now. So there's an easier way to do this than the formula. We're going to use the easier way when we can. When radians is in terms of pi, we're going to use the easy way. When it's not in terms of pi, we have to use the formula. Okay? What did I just say? When are we going to use the formula? When it's not in terms of pi. Okay. What's pi equal? 180. Yeah. So, isn't this just the same thing as this? So couldn't I figure out what that value is? How? Put in your calculator. Make sense? Pi is 180. We just substitute it in. Now, when it's not in terms of pi, that's when we have to use the degrees over radians equals 180 over pi. So what do we get? Huh? 150. Degrees. Control apostrophe. Good. I want you to do B and C, please. Mike, 3 pi over 2, what's it equal? 270 degrees. Good. Amanda, 3 pi over 4, what's it equal? 135 degrees. Thank you. Sorry, I couldn't hear you. Any problems? Okay, I gave you quite the packet of stuff. The reason I gave you so much is because this lesson is very important, that I need to make sure that you have it down pat, okay? Because this plays huge for the rest of the year. I'm going to have you circle questions. There's going to be more than 10. I apologize in advance. But are they really hard or long? No, so they should go relatively quickly. Okay, for number 1 on page 237, please circle A and C. For number 2, A and D. For number 3, A and D. 4, 5, 6, 7. Those are multiple choice. Right, but should be able to do that one. Okay, 241. And now here's where I'm going to apologize. All of 1, all of 2. This is what you just did, converting from radians to degrees, degrees to radians. Did it take you long? No. All of 1, all of 2, all of 3. All of 4, 5, 6, 7, 8. Like I said, guys, these are quick. You'll be able to move through these quickly. They don't take you long, so I know it seems like a lot, but it's really not that bad. End of the marking period, Thursday. I have to have everything in by Thursday. My grades are due. I need to get them in. Okay, so if your name is on my board, I want them ASAP. Okay, I'm after school today. I'm after school tomorrow. If I don't have them by 3 o'clock tomorrow, it goes to a 0. And zeros do not average in nicely. Okay, so make sure those get into me as soon as possible.